Now, I explained in the denominator we have the binomial, no? Que es a, particular case of polynomial. Polynomial you call when you have four or more than four. It's a trinomial, bang, 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 1, 2, 3, and 1, 2 is a binomial. Binomial expression and the degree is 1 because you see que the exponent, que by the way is invisible, is 1 here, right? Entonces, bueno, okay. We are doing in two different ways. We are doing with long division. And after I want to explain synthetic division. And you decide what way you consider better for you. Division. What is the difference? And what is the advantage and disadvantage? Long division or synthetic division. Long division is universal. Long division we can use it always, independent of the degree. You divide polynomial degree 4 and divide by polynomial degree 3, or degree 2, or degree 1. However, synthetic, no. Synthetic is like a shortcut. It's easier. The student prefers synthetic. However, the disadvantage is que long synthetic division is only apply in that case when the degree of the polynomial in the bottom is 1. Si the degree is 2, sorry, no synthetic division. Okay? Well, no more blah, blah, blah. Let's move on. Long division first. Long division is, this is the typical format of the long division. You copy that symbol, you copy inside the box the polynomial at the top. Oh, noise. And you copy outside the box the polynomial at the bottom. Okay, this is the typical format of the long division. We are doing from the elementary school. Now I need to find here one expression que multiply by this expression. Es obvio que in this case is x. Because x times x, I multiply like that, is x squared. And x times 9 is 9x. I put it here. Okay, now subtracting. Why subtracting? Because division, guys, is the procedure que you are doing. Multiplication, subtraction, multiplication, subtraction, multiplication, subtraction. This is typical division. For example, you divide 5 divided by 2. So it's 2. 2 times 2 is 4. Multiplication, and now subtract 1. This is typical division. Is multiplication and subtraction. Multiplication and subtraction. Now, to subtracting, you change the sign. You put minus, or not necessarily minus, opposite sign. And this cancel always happen. But this no, 6x. And bring down 54. I finish. No. Why no? Because you need to know that we finish when the degree of the remainder is less than degree of the divisor. This is divisor. Degree of the divisor is obvio que 1. Degree of the remainder is obvio que 1. Because we don't finish. We continue until the degree of the remainder is 0. Okay, because degree of the divisor is clear que doesn't change. It's 1. Now, bueno, okay. Entonces now I, for example, I continue. I try to find one expression and multiply by this. Give me exactly this. Exactly this. Okay, it's obvious que es minus 6. You put minus 6 here and you multiply. Minus 6 times x is minus 6x. And when you multiply minus 6 times 9 is minus 54. But by subtracting, you change the sign. And of course, everything is cancelled, remain the 0. Not always happen, but in this case happen. And the answer for this problem is this. The quotient is the answer. The answer is called quotient. If you want to check in, see everything is okay or no, you multiply the answer against x minus 6 times the divisor is x plus 9. And you foil because it's a typical multiplication for the binomial. Multiply x times x squared. X times 9 is 9x. Minus 6 times x is minus 6x. Minus 6 times plus 9 is minus 54. And we combine like that always. X squared plus 3x minus 54. And we come back at the beginning. This is the original numerator. This one. But not necessary to do this. I did to illustrate this. But it's totally optional. Yeah, so you want to make sure. Do you remember this or not?
Yes.
Okay, so now, curiosity. Let's do it by synthetic division. Synthetic division is similar, it's like a shortcut to do fast. So what's the idea? Well, you copy the same format, but you copy only the coefficients in front of the variable, okay? 1, 3, and minus 54. So you default, you suppose, that this is x to the 0, x to the 1, and x to the 2nd. You suppose this. Nobody say, but you suppose. Suppose this. And in the divisor part, you omit the variable, in this case, but you put the opposite sign to the number. The original is x plus 9, you put negative 9. Why? Well, remember, the long division you multiply and subtracting, and by subtracting you change the sign. Well, I change the sign, but only one time. This is the advantage, the good thing of the synthetic division. You change only one time the sign. And this is valid for every step. I put the line, only one, and you bring down 1. Don't do anything, just bring down. Boom, 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 boom. Now multiplication. Multiplication who? 1 times negative 9. 1 times negative 9 es obvio que es negative 9. Que es negative 9. Entonces now subtracting this column is minus 6. And minus 6 times minus 9 is 54 positive. And you, I can see the word. I don't know why. Do you see my whiteboard or no? Everyone saw my whiteboard. Caleb dice que...
Yes.
Okay, Caleb, it's your problem. Try to fix it. Never mind, okay. 0. This is important. This 0 is this 0. Okay, the remainder. No always is 0, but in this case, is some porque bring is 0. No? And what's the answer then? What is the final answer? Well, the final answer is that part. This is x to the 0. This is x to the 1. My final answer is x minus 6. Boom. Exactly like that. This is synthetic division. This is long division. Either way, the way you consider better for you. I don't care. Remember the restrictions for the synthetic division is only when the divisor is degree 1. Otherwise, no. Okay? Any question? Do you remember very well? Go ahead. Go ahead. I don't hear.
So you multiply the 1 by negative 9, and then you multiply everything else by negative 9? Is that what you did?
Yes. The action, let me explain again. The action in synthetic division is your question, miss, right? You bring down this one. Don't do anything. And you multiply 1 times negative 9 is negative 9. Yeah, I copy here. Now, subtraction. Positive 3 minus 9 is minus 6. And one more time, you multiply minus 6 times negative 9. It's positive 54. Finally, again combine. Clear?
Yeah, thank you.
Cool. Cool, cool, cool. Let's move on to another example. We have two more examples. Cool. Let me see. Delete. Okay. Next example. Next example is x squared division. X squared minus 12x plus 32 divided by x minus 4. Okay. Let's do it now like a long division. Es obvio que es x, because x times x is x squared, and x times negative 4 is negative 4x, and by subtracting, change the sign. Cancel out, all will happen, and it's a negative 8, and bring down 32. Now it's obvious que es minus a, because minus a times x is minus ax, and minus a minus times minus positive, 32. But by subtracting, you change the sign. Again, it's 0, and this is my final answer. Okay, by the way, the final answer in the first one was this, and the final answer in the second was this. Cool? No problema. Well, one more. You let me know si you understand or no, guys. Clear or no? No answer. Yes, Eric, thank you. Okay, next is y squared plus 10y plus 25 divided by y plus 5. Okay, long division, long division, long division. Y squared plus 10y plus 25. Y plus 5. Okay, you organize. Dividend is the technical name of this. Dividend. And this is a divisor. Divisor. Dividend inside the box. Divisor outside the box. And we start. It's a y. Because y times y is y squared. And y times 5, 5y. Change the sign. By subtracting. This is cancel. This is 10y. Bring down 25. Because we continue, no? We have to continue. Entonces now is, sorry, I make a mistake, no? Here 5. Because 10 minus 5, 5. And now, again, plus 5. 5 times y, 5y. 5 times 5 is 25. By subtracting, change the sign. Everything is cancelled, remain the 0. Not necessarily always remain the 0, but in this example, yes. Nice. And this is my final answer. Y plus 5. Let me see. There you go. Y plus 5. You want to verify. You want to verify if this answer is good. Okay, you multiply the quotient multiplication by divisor. In this case, they are identical twin brothers. Basically, the multiplication to confirmation, no mandatory, is quotient times divisor. Entonces, y times y squared plus 5y plus 5y again because they are twin brothers and 25. And right now you combine 5 plus 5 is 10. We have y squared plus 10y plus 25 exactly we have at the beginning. Cool. Everyone follow me or no? Yes or no?
Yes.
Okay, cool. Now, we start in details. All right. We start now in detail factorization. Factorization is no big deal. Okay, Eddie say yes. Factorization is no big deal, but pay attention, guys. Uh, the problem is that the student forgot because it's a little bit long to understand this. So we have different steps, and you need to follow it. You respect the order of this step. The first thing, number one, okay, you need to find, in order to do the factorization, is find the GCF. GCF. What is the GCF? It's greater common factor. Okay. Suppose we have different number. When we practice in the problem, you have, for example, the first example is 40, 40, 40, x to the 7 power, y to the 8 power, plus 72, x squared, y 6, plus 72, again, repetition, x to the 4, and y to the 3rd. Okay. The challenge now is find the GCF. But don't worry, be happy. We are doing step by step. So you find the GCF, in between 40, 72. In this case, a coincidence is 72. So not necessary to copy 72 again. No, it's because there's repeated. Not always happen, but in this case, happen. So to find that, don't guessing. You apply systematic way. What is the systematic way? You take 40, you take 72, and you break it down in prime factorization. Bueno, 40 is even, divided by 2 is 20. 20 again is even, divided by 2 is 10. And 10 is even, divided by 2 is 5. Therefore, 40 is equivalent in my mind, like a 2 times 2 times 2 times 5. Or, if you prefer, to don't do too long, you put 2 to the 3rd power times 5. Because we have 1, 2, 3. Cool? However, 72 is also even. It's divided by 2 is 36. You put in a calculator, guys, if you want. Divided by 2 again is 18. Divided by 2 now is 9. And 9 is 3 and 3. Therefore, 72 is 2 times 2 times 2 times 3 times 3. Or 2 to the cubic power times 3. The second power, because we have 2, 3. Okay, so now my goal is determine the greater common factor. The word common indicate que we have the same factor. Yes, obvious, I see we have 1, 2 here, 1, 2 here, 1, 2 here, 1, 2 here, 1, 2 here. This number, 40 and 72, share 3, 2. And unfortunately, 40 contain 1 extra 5, or 72 have no 5, no common, and 72 have 2, 3, but 40 have no 3. So the only common is, the conclusion is 3, 2, 2, 2, 2, but you multiply it because it's factors. 2 times 2 is 4, times 2 is 8. So the great common factor between 40 and 72 is obvious 8. Yes or no? Do you follow me? So that basic, Eric. Now we dedicate to investigate the great common factor of the variable part. So x to the 7, x to the 2nd, and x to the 4th. So you take variable by variable. So you take x, x, and x. And what is the great common factor between these? Bueno, I am lost. I have no idea. But let me try to find what the rule. X to the 7 is 1, 2, 3, 4, 5, 6, and 7x. It's the multiplication 7. X to the second is just 2. Nice. I like that. And x to the 4 is 4. 1, 2, 3, and 4. Basically, what is the common part? Oh no, the common part is this. Right? And the common part is 2x. So basically is x squared. Conclusion, you don't need to do that part. The shortcut is you take the smaller exponent. The smaller exponent is the greater common factor. Okay? Likewise, in the y part, the greater common factor, and between y to the 8, comma, y to the 6, comma, y to the third, is obvious que y to the third, by the same idea. Okay, entonces, what is my general greater common factor? Consider numerical part and variable part. Oh, it's 8x squared y cubed. Everyone follow me so far?
Yes, Professor.
Aha. Now, it's a super important moment. When you determine GCF, you factor out this GCF. You put 8x squared y cubic. You open new parenthesis. And inside the new parenthesis, I copy the remainder part when you put outside the greater common factor. Pero slow down. I am doing step by step, not too fast. For example, I go to the first guy, get 40. You factor out 8. That means that these two go outside the expression and stay only 5. Because it's obvious, no? It is 8 times 5, 40. And so you factor out 2, in the first term, in the first monomial, you have 7, entonces stay 5. And so you factor out 3, you have 8, entonces stay y to the 5th power. Do you understand this is exponent? Where come from this exponent? Do you understand?
Yes.
Because 2 plus 5 is 7, no? And 3 plus 5 is 8. So as you go backward, remember the factorization is more complicated, but it's you break it down. However, the multiplication, no, put together. And we come back at the beginning, no? So you want to verify, okay, we are doing well. You multiply 8 times 5, 40, okay. X to the second power, x to the second power, times x to the 5th power is x to the 7th power. And likewise, y to the 3rd power times y to the 5th power is y to the 8. Exactly we have here. Plus what? Plus 9, because the factor out 8, que es 2, stay this factor, 3, que basically together is 9. Not necessary to put 3 times 3. No, hello. And 9 what? 9. No x, because you have here only 2x, x squared. And you factor out, entonces es no x. And y to the 3rd power, because you have 6. And you factor out 3 and stay inside 3. Plus another 9. Another 9, by the same reason, is the same number. Entonces x to the second, okay, cool. Because it's 4. And y, no y. Because we have here y to the cubic, you factor out y to the cubic. Final answer, is the answer. Let me summarize quickly. Important. Find the GCF. Numerical part and variable by variable. Now, when you have the GCF, you put outside, open parentheses, and analyze little by little, step by step, each term, what part remain after when you put outside the GCF? Okay. Let me select what the answer we consider correct. Hey, me guy, yeah. I suppose que the first one, yeah. It's this one. Let me check it, double check it. Oh yes. Oh yes. Any question? You need to know very well. This is the first first technique to do the factorization, GCF. Factorization for GCF. I want to complicate more this. So you need to master very well GCF. And after GCF, we come in another idea, no? But this is the first one, and this is super important. GCF, GCF, GCF. Let's practice GCF. GCF. Very common fact. Okay. Okay, GCF. Okay. Some 5 say 6 x to the 12 minus 12 x to the 9 plus 18 x to the 6 minus 24 x to the cube. Okay, entonces my goal is find GCF. Find GCF, find GCF, GCF. Entonces I find GCF between 6, 12. I don't care the sign. The sign is not important to find the GCF. That's the same si es positive or negative. 18 and 24. We can use intuition. O sea, no necessarily do in the systematic way, you break it down, you select, but okay, according to my intuition, the GCF is obvious 6. Because 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. But okay. Suppose que I don't know. Okay, I don't know. I'm not sure. You take every number, 6, 12, 18, and 24. And you are doing the factorization. This is 2, 3. This is 2, 6, 2, 3. This is 2, 9, 3, 3. And this is 2, 12. And this is 2, 6, 2, 3. Okay, cool. This is the primary factorization, everything. So now this is a crucial moment in which you analyze what's the common factor. To look, you select either two. At least these two is common. And 1, 3 is also common. Look, either. What more common? Well, no, 6 have no more factors. 12 have extra 2. No. We need to find a number que matching in everything. Entonces es obvio que es 2 and 3 together que es 6. Do you see? Okay, entonces the intuition works, so you are doing well. Okay, not necessary to do everything. Okay, entonces now what about the variable? 6 is a numerical graded common factor, and x I saw x. Pero how many x? How many x you put outside the factorization? Only one? Come on, guy, help me. Only one x you factor out?
No, 3.
No. 3. How do you know get 3? How do you know get 3? What is the reason? Get 3. Because it's a smaller exponent, right? 12, 9, 6, 3. You take a smaller exponent. It's a great common factor. Super easy. Now, who helped me to put the number inside the parentheses? You factor out that 6 outside. There's not 6 anymore in the first monomial. because I put out, and we factor out 3, entonces stay 9, ¿no? And coefficient here is 1. Minus 2, x to the 6, 6 plus 3 is 9, plus 3, x to the third power, because 3 plus 3 is 6, minus 4, ¿no? Entonces, in my mind, look, 24. 24 is, si you factor out the red part, que es 2 and 3, stay alive in 24 to 2. To 2 together is 4. Final answer. Any question? No problema, Eric say. Okay, it's important, extremely important, and you don't forget this technique. GCF, GCF, GCF. Okay, let me select what do you consider the final answer is correct. Suppose que es, you help me. I suppose que es C, right? I suppose. Yeah, it's C. I see. Let's doing number 6 problem. GCF. When you face one problem of the factorization, the first thing you should do is find the GCF. Sometimes happen. Okay, it's no GCF. Well, no, it's not. You know, there are no common factors, entonces the GCF es 1. Y si es 1, entonces es completely useless. No necessary to. But okay, no problem. Let me go to number 6, is y to the 4 minus 47 y w6 plus 7y cubic w8 minus 11 y4 w6. Wow, it's a weird, because the numerical parts of the GCF and between, look, the coefficient here is 1, 7, 7 and 11, they are prime number. Everything is prime. Bueno, except 1, que by definition no prime. Entonces, es obvio que no. We have no common factor. It's a classical example que no. And, bueno, actually, yes. Always the common factor is 1. Entonces no, the coefficients stay the same. This is not important. However, we can find GCF in the variable part. I know that y is common. Let me see. Y. Okay. And W also. No, W no. W here, W here, W here, but not W here. So the only common factor is Y. But I need to investigate what exponent. Why do the what exponent you consider? Huh?
3.
3. Look, miss. We have y here to the 1 power. Then,
Yes.
oh, the smaller exponent is invisible. This is, you know, don't frustrate for this. This is the, it's a problem it's doing to confuse the students. You don't see very well that we have one y here hiding here. The y is a common factor. Open parenthesis, y cubic. You have 4, factor out 1, minus 47, stay the same. This y go outside, W6. Plus 7, y second, W8. Remember, W is no common factor. No factor out. Minus 11, y cubic, W6. End the story. End the story, end the story, end the story. I suppose it is this answer. Option A again. 7W. Okay, cool. That's the answer, yeah. Do you understand very well GCF? Excellent, excellent. This is important for me. Do you understand this? I promise in your moment when we finish to cover every technique of the factorization, we come back again to generalize the the fundamental strategy. But well, today no. Today is the first day. So we study one by one separately, and now I want in one moment integrate everything. Okay, so now let's move on to the fact to the another technique of the factorization. Let's call it factorization by grouping. Factorization by grouping. Factorization by grouping. And by grouping is classical. You know very well que grouping because we have polynomial four terms. You have four terms. Es obvio que es grouping. However, bueno, in the other example, we have 410 and you don't apply grouping, professor. The reason is because R, for example, number 7, R cubic plus R squared plus 5R plus 5. In this example, the greater common factor in between this expression, and this expression is nothing, is 1. And the reason is because in the first term, we have R cubic, R squared, and R. 1, 2, 3, R is common. But in the last one, we have no R. However, in the two last term, we have 5, but in the other, we have no. In the whole expression, we have no GCF. This is the new thing that brings me this example. Entonces, what is the solution, professor? Bueno, the solution is grouping. So my recommendation is you grouping the first couple and the second. Okay? Not always happen, not always work. The majority, 99% of the time, this combination is good. Suppose que it's not good, and you detect that it's not good, explain in your moment now. Entonces you try to create another arrangement, not necessarily the first and the second, maybe the first and the so you move another arrangement. But in this case, okay. So what is the GCF? Your mind working like that. GCF between R cubic and R squared. What's the GCF? Let me go over here. GCF and between R cubic and R squared. I forgot temporary the green part. I focus it in the red part. And what is the great common factor between R cubic and R squared? Help me.
R squared.
Exactly. Very well. You factor out R squared. We have R plus 1. Makes sense? Remember, open new parentheses. So we are doing exactly the same in the previous example, but we focus it only in the red part. Grouping. Entonces, what is the GCF? In between 5R and 5. 5R and 5.
5.
5. They factor out 5. Open new parenthesis, we have R plus 1. Oh, and this is the most important moment. The most important moment, because to be happy, I need this binomial would be equal to this binomial. See, it's different. To say something wrong happened. Maybe my combination is no good, or I need to do something extra. You see que in some example happen. So now in this moment, I realize that R plus 1 is a common factor again, and you factorization 2 times, one more time. So it's R squared plus 5. Okay. Let me explain detail. I detecting this factor and this factor is the same. I factor out. I put outside. And open new parenthesis, que is the last one, by the way. And in the last parenthesis, you put this factor r squared here in the first place, e5 in the second place. Do you see the organization? Do you see or no?
Yes.
Ah,
Yes.
okay, cool. So this is my final answer. This is my final answer. This is my final answer. Factorization by grouping. Entonces es easy, because the only thing you should do is separate my problem into two problems. Entonces you focus it one by one separately. Entonces my first problem, find the GCF factorization, nice. And my second piece, again, great common factors, is separate. But the succeed of this technique is that you have the same binomial. See, you have different, oh, my organization is not good, or something we are having. Okay, entonces, what is the final answer? The final answer is, okay, is this, I suppose. It's important to say something. This is factorization, and the order of the factor is completely irrelevant. So you remember, 3 times 5 is equal to 5 times 3. You write the different order of the factorization, I don't care. It's the same expression. Good. Okay. We manipulate in that way. However, when I go to select the correct answer, I see it's completely opposite. It's the same. Okay, the order is not important. Okay. You follow me? Factorization by grouping. Let's practice grouping. Okay, next is t squared plus 80 plus 90 plus 72. Okay. So now, again, the same idea. You select, well, obviously, it's not GCF in this entire expression F1, because we have no t here. 172, I know it's 9 times 8, and between this and this, yes. In between this and this, yes, but we have no t here. So obviously, no. So it's completely useless. This technique GCF, pure GCF, no good. Now, but grouping, yes, because I see we have common factor here, and we see we have common factor here. What is the GCF and the red part?
T.
T, open parenthesis, T plus A. What is the GCF and the green part?
9.
9, because I know that 72 is 9 times 8, no? Okay, so in my mind, this is working like a 9 and 8, no? You see, wow, 9 is common factor. Factor out 9, you have T plus A. By the way, this A is this. So in this moment, I am happy, because the factor T plus A is common. I factor out T plus A. Open second parenthesis. In the second parenthesis, we have T plus. Do you see that? Final answer.
Yes.
Final answer. Factorization. We are learning factorization. T plus A, T plus 9. It's the option A. Okay, guys. So important, extremely important. You see why it's important. So without factorization, you don't understand very well. You are in big trouble to continue, not only in this subject, you in the rest of the mathematics you need to take. Because frequently we are using this. X cubed plus 3x squared, we are doing number 9, plus 6x plus 18. Oh, wow, wow. GCF, do not exist GCF. Bueno, S1. Do not exist is not true. S1, the GCF, but S1 is useless. No important. And again by grouping. Red one, green one. What is the GCF in the red part?
X2.
X squared. New x plus 3. Okay? What is the GCF in the green part?
6.
6. Out 6. X plus 3. Happy. I am happy. Look at my face. This is me. Why is the reason I am happy? Because this factor is the same. Not always happen. I warning you, not always happen, right? In this case, happen, I am happy. I am happy, therefore I am happy. This is the game of word. Happen, happy. Okay, entonces, therefore, x plus 3 is a common factor que factor out. Open the last parenthesis. Inside we have x squared plus 6. Okay, let me try. X plus 6, x squared plus 3. Suppose que es D. Cool? Oui. Cool?
Yes.
I have a smart class. Everyone follow me. You remember very well in high school? I know that the teacher in high school is playing very well that part. So pero es important. Recall. UB is a multiplication of two variables. UB minus 7U plus 5B minus 35. Okay, grouping again. It's obvious that we have no common factor in the entire expression. However, here, maybe, I am not sure, work or doesn't work, I don't know. Entonces, the great common factor in the first copy is obvious que U, right? B minus 7. The great common factor in the green part is obvious que 5. B minus 7, no? Because 35 is 5 and 7. So you factor out this 5 out, stay 7. Copy again. B minus 7 times U plus 5. B minus 7, U plus 5. This option. Any question? No? Okay, let's move on to the next page. I promise that this would be complicated. Maybe look like easy now, but in your moment, we see more complicated, no? Okay, cool. This is the second page of the package I sent to you today in the email. Okay, let's practice a little bit more factorization by grouping, no? Two more examples, 11 and 12. This is 6. The variables are, no x. 6r squared plus 27 ry minus 2xr minus 9xy, ¿no? Bueno, es obvio que no common factor. Therefore, I try by my best by grouping. Entonces, what is the common factor in the red part? The red part is 3, because 6 is 2 times 3, and 27 is 3 times 3 times 3. So it's 3r. We have 2r plus 9y. Okay. Now, in the second part, in the green part, you see too many negatives. So es obvio que the common factor only is x, ¿no? Pero entonces you factor out positive x, or negative x. This is challenging. It's obvious que much better negative a because when you factor out negative x in the parentheses, in the new parenthesis, no, we have everything in positive, no? The 2r. Wow, I like that. Again, the same situation. Entonces, this problem bring me this new idea. Sometimes it's useful factorization, not necessarily positive factor, no, sometimes negative factor, in order to guarantee that this and this would be the same. So now ready. 2r plus 9y, open the last parenthesis, 2r minus x. See, 2r plus 9y, 3r minus x, I suppose que es this. Cool. Everything okay?
Yes.
Let's try the last one of grouping. 12 minus 6y minus 2x plus yx. At the beginning, I have no idea, totally lost. I see clear que is no common factor in the whole entire expression, pero maybe by couple, yes. Grouping is the idea. Okay, now the great common factor in the first couple in the red part is 6, positive 6, and we have 2 minus y. And the second I see is x, but you factor out minus x, and we have 2 positive. Remember, it's positive because when you multiply negative x times positive 2 is negative 2x, exactly like the original. This is minus y. Let me see, I am not sure. Negative times negative positive. Okay, cool. Now ready. 2 minus y is a common factor, and the last parenthesis we have 6 minus x. Minus. Okay. Minus y, 6, this one. Entonces, en grouping, you feel comfortable?
Yes.
Okay. Let's move on to the trinomial. And the factorization using trinomial is very, very, very complicated because we have 3 scenarios. We have 3 cases. Okay, we have the regular case. The regular case is, let me show you, let me explain. The regular case is when you have trinomial, when you identification is trinomial because it's 3 terms. No? So for example, let's do it 13. 13 say factorization x squared plus 7x plus 12. Okay, factorization of the trinomial always, when it's possible, of course, is 2 binomial multiply. So you open 2 parentheses. Don't hesitate to open 2 parentheses. And you put a name of the variable que says. Okay? This is 1 second to do this job. And the rest of the time you explain in the central idea que is the most complicated. I need to find 2 numbers que I don't know. And multiply each other. Give me 12. And 12 is this number. And this number again, I copy down. Again, you add in and sometimes subtraction, depending the problem. Maybe plus or maybe you get 7. This is the idea. Of course, you are doing this operation mentally. I want to explain different technique. Don't worry too much for this. Es obvio que our fantastic combination is 3 and 4, no? 3 times 4 is 12, and 3 plus, in this case, no minus, no plus, is 7. And you copy 3 and 4. 3 and 4. I don't know why I like so much copy the big number first. I don't know, in my brain, but not necessary. And you obviously, you put a sign que es plus plus. I explain and tell the sign, que es the complicated part. But in this case, super easy because everything is positive. So we have two signs in the trinomial. No? This is one sign and this is another sign. And in this case, both are positive. Let me take advantage this moment to call, for example, this is my first sign. And this is my second, no? Well, it's the name according to the order. You see from left to right, this is the first and this is the second sign. In this case, both are positive. This is obvious. Okay. And that's it. No. Why no? You need to mandatory, guys, because sometimes it doesn't work. You checking this. And for checking this, you are doing FOIL. We're doing the opposite operation of the factorization, okay? The multiplication, you multiply this binomial using FOIL, and we come back at the beginning. So we come back to the same, cool. You see, well, professor, what is the reason? I need to check it. The reason is clear, because sometimes, in this case, it's a straightforward problem, but sometimes we have two combinations. They work, or hypothetically work. However, only one is the actual answer because the factorization is unique. As you assume one combination, and when you FOIL, you don't come back to the original. So this combination is wrong, and you need to select another combination. In this case, no. This case is easy. Is to apply FOIL x squared. You apply FOIL 3s. Apply FOIL 4s, apply FOIL 12. And when you combine that term, 3 plus 4 is 7x. We have x squared plus 7x plus 12, exactly like the original. Well, professor, but what is my answer? My answer is this. This is my final answer. This is my beautiful final answer, no? The rest is just checking, verification, no? This is the original I put in the box. It's original. This is the checking part. If you want in the test, you check in one corner of the piece of paper, but you checking, and you erase if you want, because it's just a checking to verify that we are doing well. And this is my beautiful final answer. I put in the box as always. I highlight and record. Cool. Okay, I do not explain completely the idea. Let me do one more or two more because I generalize the idea. Let's do it 14. Well, where are we below? Let me check it. What the answer is? The answer is this. 4 epic. Okay, let's move on to 14. Is u squared minus 9u plus 14. Okay, immediately open two parentheses because I know very well that this is factorization trinomial, and the factorization of trinomials is possible. It's two binomial. And you put the name of the variable in this case. I try to find the combination. Okay, one fantastic way to find the combination is, well, you can use your skill in arithmetic, but you need to organize the word. No? So now, my recommendation is you take 14 and you analyze the factor of 14. So 14 is 14 times 1. But 14 is also 7 times 2. See, there are more combinations. Well, you write more combinations, but in this case, no, 2. And you adding to find every combination. You adding plus, subtracting minus, adding, subtracting. But this is totally mental. This is 15. This is 13. 14 plus 1, 15. 14 minus 1, 13. And 15 and 13 is no 9. I need 9. to find the fantastic, the combination que open the door. And 7 plus 2 is 9. Ooh, I got it. It's the answer. Entonces 7 minus 2 is 5. No, I don't care. I found. Got it. Okay, so you copy 7 and 2. Remember, in my mind, I put the bigger first. I don't know why. And let's doing the sign. Well, the sign is, this is a crucial moment, guys. Remember, in the trinomial, we have two signs. Calculate in your moment, first sign and second sign. What is the rule of adjust the sign? Listen to me now. If the second sign is the first sign que you analyze, is positive, it is the case that we are doing in this problem, The conclusion is we have the same sign. What means same sign? Remember, we have four possibilities, no? We have plus plus. Like this example, it was plus plus. We have minus minus. We have plus minus, or we have minus plus. We have four combinations. But in this combination, we have same sign. In this case, no, we have different sign. In this case, when this first, with the second sign, sorry, is positive, we expect the same sign. And what sign? Plus plus or minus minus? In this case, minus minus, because this minus is the sign, the first sign, is negative. Okay, conclusion. In few words, if you take a look, focus your eyes directly to the second sign. This is the key to open the door. Open the door. And when you open this, you see it's positive, automatically, I know, okay, we have the same sign. Same sign means plus plus or minus minus. And to say, how do you know? When you're looking now, the first sign. The first sign is positive, both positive. The first sign is negative, both negative. End the story. Are we finished? No. We finished no, because what happened if the second sign is the first sign you need to take a look is negative? Automatically, I know that we expect different sign. Different sign is this situation, plus minus, minus plus. I know, professor, but what is plus or what is minus? Okay, the conclusion is the bigger number. Entonces now another conclusion after that, the greater number has the first sign. Important. Let me try one more example to generalize this idea. Example 14. Example 14 is I did 14, huh? Yeah. 14, the answer was this. I did that here. Now 15. 15 is x squared minus x minus 6. Wow. When I know the trinomial, open two parentheses, put the variable, get x. I need to find, I don't care the sign, no. I need to find the combination that open the door. Combination that open the door is, I don't know, 6 is 6 and 1. But it's also 3 times 2. This is the only possibility of factor 6. 6 and 1, I suppose que is weird. doesn't work because when you're adding a 7, when you're subtracting a 5, yeah, I need 1 here. Look, the middle term is 1. Actually, it's negative 1, but I don't care the sign in this moment. Entonces, si you adding 3 plus 2, again es 5. So si you subtracting is 1. Entonces, this is my combination, 3 and 2. Can you copy 3 and 2? Entonces, this is the moment to adjust the signs according to the rule. My second sign is negative. Look, this is this case. This is an area. So we expect different sign. No, the same. No. Different. Who is positive? Who is negative? Well. The bigger, it's important. The greater number gets 3. Obviously, it have the sign of this. It's a negative, and it's a positive. And to make sure you foil, this is checking. This is just checking. X times x, x squared. X times 2, 2x. Minus 3 times minus 3x. Minus 3 times positive 2 is minus 6. When you combine, basically you combine always the outer and the inner product, because I know that the outer and inner product together give me the middle term. Middle term. And when you subtract, obviously 2 positive minus f minus x. So my answer is x squared minus x minus 6, like that. It's exactly coincident to the original problem. Okay, now this is completely double checking, no important. There's a confirmation that we are doing well. And this is my beautiful final answer. That one. Not this. This is the original. Okay. We're checking. It's x minus 3. And we're doing what number we're doing? I lost. No, we are doing number 15. It's a 15. 15. 1, 5. 15 is x minus 3. X plus 2. X this one. Remember, the order is totally irrelevant. This is the multiplication. It's factors. X minus 3, x plus 2. X minus 3, x plus 2. Do you follow me? Do you understand very well the convention for the sign or no? Come on, guys.
Yes.
Okay. Cool. Okay, what's happening? It's doing now number. I don't know. 16. Yes, 16. 16 is x squared plus 4x minus 21. Bueno, 21 is relatively easy. 21 is 21 times 1. So this combination doesn't work. When you adding is 22. When you subtracting is 20. Much better is 7 times 3. You're subtracting 7 minus 3 is 4. Exactly. We open two parentheses. With the combination, guys, hypothetically, I suppose que work. Okay, 7 and 3. And adjust the sign. We have different sign, it's obvious, because the second sign is negative. And the big one, que is 7, is the sign, the first sign. So this is plus, and this is minus. Never, I am trust 100% with this. I need to FOIL and verification. X times x squared minus 3x plus 7x plus 21. You combine this, 4, positive 4. Exactly like the original, and this is my final answer. Okay, guys. So therefore, you analyze sequentially first the second sign. This second sign open the door to analyze. We have minus. Oh, minus is plus minus or minus plus. How do you know? 50-50. Well, it's a plus minus because this first sign is plus. And always the sign, the first sign you assign, you copy, 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 and paste, paste, paste onto the big factor or greater factor. Okay, entonces x plus 7, x minus 3, boom. It's this guy. We are doing guy factorization trinomial. But this is the easy trinomial. Easy, easy, easy trinomial. Why is easy? How do you know it's easy? It's easy because coefficient here is 1. The coefficient is not 1. It's 2, it's 3. Entonces it's a little bit complicated. No, it's similar procedure. Similar, not the same. But you identify, you take advantage. Oh, it's easy trinomial because the coefficient in front, the x squared is 1. Nice. I like that. You open two parentheses, you put a variable, you try to find the combination that open the door, and finally, you adjust the sign. Okay. Si es another trinomial, more complicated. I suppose que not today. Don't cover today this example. We cover next time. Trinomial is the most complicated part. Si you master very well trinomial, you have no problem in the factorization. Because binomial is easy, and GCF is easy, and group is easy. The complicated part is trinomial. But don't worry, I explain step by step. We are doing easy trinomial. Now, 17. 17 is x squared minus 2x minus 80. Wow, what the hell? 80. Entonces now I have no idea. I copy here 80 is 80 times 1, but never you get to this combination now. Now 40 times 2, never you get that. You go 42 and 38, no. And we continue, divided by 3, no. Divided by 4, yes. Is 20. 20 times 4 is another combination to give me 80, no? 24 and 16, no? I need to continue. Maybe it's too long, and you spend time doing this, but you put in a calculator, no? Put 18 divided by 4, 20, and divided by 5, yeah, let me try my calculators. 80 divided by 5, division 5, 16, I guess, so 16 and 5 is also 80, but when you adding is 21, and when you subtracting is 11, we are close, little by little, divided by 6, 80 divided by 6, no, not good, it's not divisible by 6, and divided by 7, no, and divided by 8, I suppose, yes, A is easy, it's 10 and 8. 10 times 8 is 80, and addition is 18, but subtracting is 2. And this is our combination, guys. This is our combination. Okay. Wait for me, I need to go to the restroom now, okay? And it's short. And back. So if we get the combination 10 and 8, because when you're subtracting 8 minus 10 minus 8 is 2. Okay, good. So I open two parentheses. I put the name of the variable as x. I try to do my best using that combination 10 and 8. And you adjust the sign. Who helped me to adjust the sign? Who is positive, who is negative, or both positive? Remember, we have two combinations, plus plus, minus minus, plus minus, and minus plus. What do you think? It's our good combination. Tell me, who there? Nobody there? Okay, step by step. Look in the second sign, is minus, indicate us, okay, we have same or different?
Different.
Exactly. So you discard that possibility. No plus plus, no minus minus. It's this or this. However, looking the first sign is minus again. In that case, entonces who is positive, who is negative?
Ten is negative and A is positive.
This is the answer. 10 is negative and 8 is positive. Now I feel comfortable. No, never. I fail to verify. Okay, our factorization work. X times x squared. 8 times x times 8 is positive 8x minus 10x, get the multiplication innermost, and minus 80. When you come subtracting that part, because it's opposite sign, it's minus 2x. So our trinomial is x squared minus 2x minus 80, exactly like the original. Therefore, everything is okay so far. Therefore, this is my final answer. So guys, don't hesitate to do this part. This part is important. But don't try to, because some students put nervous and try to crazy. What is the combination? The combination is 40 times 2. So 40 times 2 is 42 and 38. No, doesn't work. But don't copy in the piece of paper. So you do not organize the path to go directly to the key, open the door. I recommend that you, in the one corner of the piece of paper, you try 1, 2, 3, 1 or 3. No, because when you divide 80 divided by 3 is decimal. No, that means 80 is not divisible by 3. By 5, yes. By 6, no. By 7, no. By 8, yes. And now addition, subtraction. When you get that, you said no always is nice. I don't know if you see or no another example in which you have two combinations. If you get the middle number. However, only one is good. Only one is good. Okay. I remember, for example, the classical example. I don't know if it's here or no. Okay, this situation happened. Look, classical example. Look, suppose one easy. X squared minus 5x plus 6. It's completely apart to the package. Because I remember, I want to illustrate one idea. Okay, I open two parentheses. I put x, and 6, I take 6, I analyze 6 as 6 times 1, and 3 times 2. So what is the combination, 6 and 1 or 3 times 2? When you're adding 6 plus 1 is 7, when you're subtracting 6 minus 1 is 5. Oh, I got it. However, 3 times 2 is 5 again, and 3 minus 2 is 1. So we have two possibilities in which you get 5. Then you need to make a decision because only one is good. I want to illustrate in detail now. What do you recommend me to take? 6 and 1 or 3 and 2? Come on, you give me opinion, no? Si you are wrong, we verify. You are right, no problem. What combination you consider gets good? 6 and 1 or 3 and 2?
3 and 2.
3 and 2, I agree. Okay, good. 3 and 2. And what signs? Different signs, same sign, both negative, both
Same.
positive. Say again?
Same.
Same. Entonces, what? Positive or negative?
Positive.
Okay.
Negative.
Negative. Why? How do you know que es negative? Because, okay, it's the same because this sign is positive, correct? And it is negative of bam bam because this sign is negative. And si this sign is positive, it's plus plus. But no, plus, no plus. So how you obtain this negative? They're both negative. So now, checking, mandatory, important. X times x, x squared. X times minus 2, minus 2x. Minus 3x, plus 6. Because negative 3 times negative 2 is plus 6. When you combine this and this, it's minus 5. Wow, fantastic. Exactly the same like the original. And this is solution. Let me explain now. If you, and it's logical. Remember, this arrow indicates addition. And this indicates subtraction. And this indicates addition. And this indicates subtraction. And this is 6 minus 1 and 5. I agree. However, we need to subtracting, we need different sign. And have not too much sense if this sign is plus. But okay. Suppose que another student say, bueno, professor. Suppose que in the test, I taking that combination. Six and 1. Because somehow 6 minus 1 is 5. Cool. So this is a crucial moment in which I need to make a decision, the size. Well, see, I following the rule explained the teacher. The teacher say that when this sign is positive, we expect the same sign and both negative because it's negative. So it's negative, negative. However, I realize that this combination doesn't work. Okay. Look, okay. Suppose this. I multiply for it. X squared minus x minus 6x plus 6. Cool. And when you combine here, it's minus 7. Not 5. You say, well, okay, professor, pero no. Yeah, I don't agree with you. Put 6 and 1, but maybe I put minus here, plus here. So maybe work. Okay, let's do it. You apply for it again. X squared plus x minus 6x minus 6. Cool. Because when you combine here, it's minus 5x. Oh, exactly like the original. However, what is the problem? The problem is that my original is plus 6, no minus 6. Do you see it doesn't work? Either way. Do you see? Do you see?
Yes.
Entonces now, keep in mind in this sequence, not necessarily we have only one combination. No, we have maybe no frequently, but sometimes happen that we have more than one combination. Entonces you need to discard what is the wrong combination, no? Because the factorization is unique, only one solution, not two solutions. Okay, let me try 17. But I did 17 or no? I did 17, right? I did
Yes.
17? Yeah, I did 17.
Yes.
And the 17, what was the answer? Okay, don't remember.
Sí.
C. Cool. Okay. Now let's do in 18. 18 is t squared 18 plus is t was r. It's r, no? It's r. Sorry, I don't see very well. R squared plus 2r minus 24. Okay, again, I open two parentheses. I put the RR, get the variable. I try to find the combination. 24 is 24 times 1. I suppose it doesn't work. Another 12 times 2. I suppose it doesn't work. So when you subtracting is 10. When you addition is 14. I need 2. Another possibility is 8 and 3. Not good. Another possibility is 6 and 4. 6 times 4 is 24. However, 6 minus 4 is 2. So you're adding is 10, but when you subtracting is 2. And this combination possibility works. Potential combination. And we have more. I suppose que no. Okay, this is 6 and 4. What sign? Who help me? Same sign or different?
Different.
Different. What is positive? What is negative? Who is positive? Who is negative?
6 positive and 4 negative.
Very good. Now checking. Always mandatory. R squared. Minus 4r plus 6r minus 24. You combine like term here, the 2r. Exactly like the original. Therefore, I prove mathematically that this combination is good. So far it's easy, eh? Or no? What is the complicated part? I suppose that the complicated part is this. So I recommend this organization. No? This is my recommendation. No? So you have another recommendation, another possibility. Can you feel more comfortable? It's okay. It's okay. Basically, I need to find two numbers can multiply each other. Give me 24. Get the first number. I don't care the sign. The sign is not important. And when you adding or subtracting, so I indicate addition, this arrow. Subtracting, this arrow. Addition is 25. Subtracting is 23. And I need to check and see this result is coincident or not with the middle guy. The middle is no, this combination, no good. No good. No good. And it's good. Right? Okay, so we now we are doing wait. So help me to select. R plus 6, R minus 4 is the first one. Yes. A. Good. We're doing one more. Or two more. 19 and 20. Que bring me new, pero not too complicated. It's relatively easy. Suppose this. 19. X squared plus 2xy minus 35y squared. What is the new thing can bring me this example? 19, 20, 21, and 22. Well, is can our trinomial, frequently we are working, contain only one variable, r, only one, and we have two variables, but it's the same. No big deal. You ignore, because you want, you focus in this, x squared plus 2x minus 35. Entonces, let me explain how you manipulate the y, que es the second variable. But it's the same. Entonces, now, abstraction. Y is invisible. You open the parenthesis. You put the name of the first variable, que es x, and y do not exist in my mind now. I copy 35. I try to find the combination. Get 35 times 1. No, not good. And 5 times 7. And 7 minus 5 is 2. This is the combination. The word 7 and 5. Okay, entonces 5, you copy the bigger one in my mind, you know. 7 and 5. But you include the second variable now. It's the only new thing. Why? So the trinomial contains two variables, and that part, when you write the factors here, you put the name of the second variable. And what about the signs? Who helped me with determine the sign? Get the complicated part. Que some students
different size.
And
7 positive and 5 negative.
wow, fantastic. 7 positive and 5 negative. Boom. And you check it or no? Always. Mandatory check. X times x squared. X times this is minus 5xy in alphabetic order. Multiplication here plus 7xy in alphabetic order. Minus 35y squared. When you combine like terms, 7 positive and 5 negative is 2xy positive. Exactly like the original. Boom. That's my answer. That's my answer. Is the option. Let me check in. Okay, guys. I suppose it's too much for today. We continue Wednesday. Es A, no? Again? Yeah, no?
Yes.
Okay, guys, too much. We continue Wednesday. Don't forget to send me by email. Never using external email, using the school email, guys. Because I explained external email, the cyber security of the Miami-Dade is very strictly, and maybe no, 100% send to your email external to the junk box. So I don't see, wow, this student don't send me nothing. I put 0 in the canvas, grade book. No. To avoid this, send me by the student email. Everyone have a student email, okay? Okay, guys, bye-bye. I have another class now. I need to leave. Bye-bye.
Bye, Professor.